Hello, everyone, and welcome to section 1.4. This is problem solving in chemistry. So this is where we talk a little bit about how we use problem solving skills in chemistry. So skills used in solving problems, very effective problem solving always involves developing a plan and then implementing that plan. And the skills you might use to solve a word problem in chemistry are no different in deciding what to buy in a store, for example. And we'll go through some examples of this. So for example, solving a numerical like a number problem, there's a three-step problem solving approach where we analyze, we calculate, and then we evaluate. So let's go over what that means. Analyze. This is determining what is known. So when you're looking at a numerical, a number problem in chemistry, first analyze the problem and to determine what is known. So what they give you. Then determine what is unknown. What is the problem asking for? Then you determine the units, and we'll talk about what that is, the units for the unknown, if it is a number, and then make a plan for using what is known to arrive at the unknown. Calculating. For some problems, you might have to convert a measurement from one unit to another. And for some problems, you may need to rearrange an equation before you can solve for an unknown. And then evaluate, is the answer you got reasonable? Sometimes the answer might be like really big or really small or seem way off, and you might get that right away. Does it make sense? Check to see if you copied all the numbers in the data correctly. Did you choose the right equations? And does your answer have the correct units and the correct scientific figures? So for example, let's look at estimated walking time. Sample problem 1.1. You are visiting Indianapolis. You decide to walk from the Indiana State Capitol to the Murat Center for an afternoon performance. According to the map, the shortest route from the Capitol to the theater is 8 blocks. So here we have the start and the finish. How many minutes will the trip take if you can walk 1 mile in 20 minutes? And assume that 10 blocks equals 1 mile. So I'm going to let you guys think about that for a little bit, and then we'll solve it together. The shortest route from the Capitol to the theater is 8 blocks. And it's asking for how many minutes will the trip take if you can walk 1 mile in 20 minutes. And you assume that 10 blocks is equal to 1 mile. So they give you a lot of information here. We can determine what is known. We're looking to walk 8 blocks from the Capitol to the theater. And we can walk 1 mile in 20 minutes. And 10 blocks equals a mile. So let's set up our problem here. List the knowns and the unknowns. This problem is an example of a conversion problem where one unit of measure, blocks, must be expressed in a different unit, minutes. We're trying to convert how long it takes to walk 8 blocks. So we have to convert 8 blocks to so many minutes. The knowns are the distance to be traveled, 8 blocks. The walking speed is 1 mile for 20 minutes. And 1 mile equals 10 blocks. So we've created our list of knowns. The unknowns that we need to figure out are that the time of the trip, we don't know how many minutes it takes to walk 8 blocks. That's what we're trying to figure out. Then we calculate and we solve the problem for the unknown. So we divide the number of blocks to be traveled by the number of blocks in 1 mile. And if we look at this relationship here, 1 mile is equal to 10 blocks. And that can be also interpreted as 1 mile per 10 blocks. So we're putting 8 blocks, we're multiplying it by our conversion, 1 mile per 10 blocks to get the distance in miles that we'll be traveling. So solving for the unknown, what we've done here is we've taken 8 blocks because it takes us 8 blocks to walk from the Capitol to the theater. And we know that we can walk 1 mile in 10 blocks. So we're able to multiply 8 times 1 over 10. And that gives us the total distance that we will be walking is 0.8 miles. So this will help us solve kind of the second step of the problem. Calculating and solving for the unknown, then we can multiply the number of miles by the time it takes to walk 1 mile. So we know that it takes us 20 minutes to walk 1 mile. So we can multiply the number of miles we're walking, which is 0.8. We got from the previous slide. And we multiply it by 20 because we know it takes 20 minutes to walk 1 mile. And notice how the units cancel. We're multiplying 0.8 miles times 20 minutes per mile. The miles cancel each other out, and we're left with the unknown, which is what we want, the number of minutes. So it will take us 16 minutes to walk 8 blocks, which is 0.8 miles. Does the result make sense? The answer seems reasonable, 16 minutes to walk 8 blocks. The answer has the correct unit because we wanted it to answer in minutes, and the relationships are used correctly. So that's how we evaluate. Solving numerical problems, there's also a 2-step problem-solving approach where we analyze and then solve the problem. We'll go through this answer. Let's go through another kind of sample problem, number 1.2. Manny needs to schedule his classes for next year. The school day is divided into 7 periods, and he must take Algebra 2, Art, Chemistry, English, History, and Physical Education. Using the information from the course catalog, find a way for Manny to schedule all his classes. And this is where you kind of analyze and just solve the problem by using all of the knowns that they give you. Algebra 2 is offered either during first or second. Art is offered during second period only. This is interesting. So we know he needs to take art during second period. That is a non-negotiable because that's the only time art is offered. Chemistry is offered during third or sixth period. English is offered either 6th or 7th. History is offered during 4th or 7th. Physical education is offered during 4th only. So this is another non-negotiable. We know that PE must be during his 4th period. So we already know what he's taken second period and what he's going to take the 4th period. And then lunch is scheduled for the 5th period. So we've gotten the 2nd hour down, we've got the 4th hour down, and we've got his 5th hour down. Now we just have to figure when to take algebra, but wait, algebra is either 1st or 2nd, and we already know 2nd is out of the mix because that's when he needs to take art. So algebra will be 1st, art is going to be 2nd, chemistry. Do anything else, what should we put 3rd? Looks like chemistry is the only thing offered in 3rd. So looks like chemistry is going to be 3rd. English can be 6th or 7th, and history can be 4th or 7th. Well, they can't both be 7th, so we'll put English on the 6th because that's free. Our 4th period is already taken for history, so we'll put history in the 7th. So this is just another way of analyzing this and solving a problem. And I think it'll kind of take you through this. Manny must take lunch during 5th, art during 2nd, and physical 4th. Apply the concepts to solve the problem. We can place lunch, art, and physical education into Manny's schedule because we know that's where it goes. Since art is only available during 2nd period, Manny must take Algebra 2 during 1st. Since PE is only available during 4th period, we must take history during 7th period. So then we are able to fill in the remainder of Manny's schedule. So that's a little bit of breakdown in how we'll solve problems. And in chapter 2, we'll get into a little more detail in how we solve those numerical problems. Thank you for listening, everyone, and have a good rest.